Good morning. This video is going to be about functions and whether or not they have symmetry. And specific symmetry, calling them and sorting them into a special function, either even, odd, or neither, or even symmetrical around the x-axis. All right, so even functions. If you look here, an even function has symmetry with respect to the y-axis. So it's not as easy as look at the exponent and decide whether it's even. It has to be the exponent is even, and I should say highest exponent is even. So that's the degree of your function is even, and the center is on the y-axis. So this allows the y-axis to be your folding line, that when you fold it, it will match up. So that's how you can look at a graph and know if it is symmetrical about the y-axis, is if you look, if you were to fold the piece of paper right on the y-axis, would they match up perfectly? If they would, then it is an even function. Okay, so that's how you get an even function, that's how you look. So here you can look at the table and you can see that this side is the same, and therefore you have 0, 0 in the middle, making it symmetrical on both sides. The algebraic y. So I'm never really going to have you look at a table, but I am going to ask you to be able to look at a graph and know if it's even, odd, or neither, or look at and do the algebra. The algebra is very important when it comes to calculus. This is where I usually had started teaching it when I taught calculus. Okay, so f of negative x is equal to f of x. So what that means, and the easiest example to go with, and how I would always use this to prove algebraically, is or the quick example, I should say, is f of negative 1 equal f of 1. Okay? If that's a yes, now sometimes that can happen even if they're not symmetrical, but if it's a yes for every x, then you have it symmetrical. So how you would do this is plug in a negative x. So to do algebraic linear equation, if I was to do f of negative x, that would equal negative x squared. F of regular x is equal to x squared. So now, what happens when you square a negative? It becomes positive. So are these the same? Yes. Okay. Another example, I'll show you a non-example so you see what we're doing. If I had x squared, I'm going to change that because that still will be. If I had x minus 1 squared, now let's check that out. So this is f of x, is x minus 1 squared. So now let's see, what would f of negative x be? Well, if I was to plug that in, that is negative x minus 1 and square it. To really see whether this is the same, you would have to multiply this out. So if I was to multiply out x minus 1, that is x squared minus 2x plus 1. If I was to multiply this out, that is x squared minus, that is going to be plus 2x plus 1. So you can notice that they are not the same. So this would be a non-example. And that's how you prove algebraically. So algebraically is a little bit more complicated. Looking at the graph, visually speaking, is easier. So now we're going to look at odd. So an odd function, its symmetry is right at the origin. Okay, so if you were to fold at that dot, they should fold on top of each other. It's kind of like you can kind of look at this as a rotation. When you rotate it, would it go up? And it absolutely does in this case, okay? So again, it is the odd function, but that's not the only case. It has to be highest degree odd. And has to be symmetrical, so the center is at the origin. Okay, if you don't have the center at the origin, then it is not an odd function. So here the algebraically is saying that f of negative x is the same as negative f of x, so make the whole function negative. So if you took this example, you have f of regular x is x to the third. So now plug in negative x, and you'll have a negative x to the third. Well, an odd power to a negative remains negative, so this becomes a negative x to the third. That would make them the opposite signs. So yes, an odd function. Now I'm going to make this a little bit easier. If I was to just shift this up one, it is no longer an odd function. And how I could tell that is if I put in a negative x, so that is x, negative x to the third, it's still plus 1. So now, if I look at this, it becomes negative x to the third plus 1. Well, that's not the same as opposite. If it was all opposite, you would have to change the whole thing. So your goal would be negative x to the third minus 1 for it to be odd. Because that's not what happens, this is not odd. Okay, and that is the algebraic of odd functions. Okay, so the last one is symmetry with respect to the x-axis. Okay, so symmetry with respect to the x-axis is just the dotted line down here. And here you could see your symmetry now is about the x, not the y. These is also, it's not a function, so you're not really going to find a function that is symmetrical along the x-axis, otherwise it wouldn't be a function. Alright, and so here is your algebraic way, is you just are looking at your points and that your xy is also x negative y. Your biggest symmetry would be your square root function, which we then change the domain to say that x has to be greater than or equal to 1 because it can't be 0. In order to be a function, this is what we say, but if we didn't make it a function, all square root functions would be symmetrical about the x-axis. And that is your last example. Most questions usually ask you to figure out, is it even, odd, or neither? And very little times you ever look at it, is it symmetrical to the x-axis? Because most functions aren't if they're considered a function, okay? Because as you can see here, your x's would have to have two different outcomes, which is not a function. So just be ready for most problems, especially in your book. You will see, is it a function, even, odd, or neither are the most common. Even your SATs might have an example of that.